Hello everyone. Let's start the topic. So what yesterday we were doing in the last class, we were learning about Coulson-Lewis approach for bonding, and we have seen some of the bonds, that how different bonds are formed. Okay, we have learned about that there is 2-3 types of bond. One of them is known as ionic bond, one of them is known as covalent bond, and this is formed by complete transfer of electrons. This is formed by complete transfer of electrons, and this one is formed by sharing of electrons. Okay, now in covalent only there is one more subcategory possible. Okay, normal covalent bond, one is called as normal covalent bond. Okay, and another one is known as coordinate bond. So normal covalent and coordinate, what are the differences? Let me tell you. Normal covalent is what? As you know, let us say there is a atom A, there is a atom B, and between them there are 2 electrons. Okay, bonds are being formed. This one is contributed by A and this one is contributed by B. That means there will be equal contribution. In the bonding electrons or in the sharing electrons. Then it will be considered as a normal covalent bond. Okay, or covalent bond simply. What is a coordinate bond is when one guy has 2 electrons and other guy is not sharing any of them. Both of them is of his own only, and then they form a bond. This kind of bond will be called as a coordinate bond. Is it okay? This is always shown like this with an arrow. That means this guy has given all the 2 electrons. That means he has given all the 2 electrons to, or he has given one part of his this atom's part by himself. That means A is providing the part of B also. Okay, A is providing the part of B also in the contribution of a covalent bond. This is the thing. Apart from that, if you represent them in the form of Lewis structures, what we usually do is we write a formal positive and formal negative charge. Okay, these are formal charges. Let me tell you, these are not actual charges, these are only formal charges. And formal means that they are not real. That means that they are appearing to be there. They are not actually there. Is it okay? They are appearing to be there individually. Is it okay? So A positive and B negative, it can be represented like this or they can be represented like this. Okay, tell me if there is any doubt. Anybody has any kind of doubt? Anybody has any doubt? Sir, can give example? Yeah, I will give. Wait for that. No doubt. Very good. No doubt. Example. Okay, I will give. No, very good. No doubt. Very good. Let's move. See, you have seen nitrogen with 3 hydrogen. Okay, and there will be, you know, nitrogen has 5 electrons, 3, 4 and 5. 3 of them are shared with hydrogen and one is not shared, and one pair is not shared. This kind of thing is known as NH3 or ammonia. When we add a H plus to this, tell me how many electrons are there with H plus? H plus means hydrogen with 1 electron lost. Hydrogen has only 1 electron, and if one of it is lost, then it has 0 electrons. Okay, and if this guy has to get bonded, it cannot provide any electron. It do not have any electron to provide. So what it do is nitrogen provide both of them. In between of them, nitrogen shares with it the 2 of its electrons and form a coordinate bond, and it is formed like this. See, NH3 and coordinate bond H. And because there is a plus charge on hydrogen, so this plus charge will be still there on the molecule. Similar to that kind, there is one more possibility, that is the case of O3. Oxygen has 6 electrons, okay. Now what it will be, like let us say one more oxygen is there, with it has shared already, let us say 2 electrons, one here and one here, 1 2 3 4, okay. Now one more oxygen is there, let us say 2 4 6, okay. If it will try to share with this electron, sorry, if this oxygen will try to share with this oxygen, what will happen is it will get more than 8 electrons. That's why what it do is it shares like this, and what it forms is O double bond O, coordinate bond O. Now see, coordinate bond means its 6 will remain intact with it, okay. It will have 2 with it because 2 of them are used in coordinate bond, and one here, one here. For this oxygen, one here, 1 2 3 4, okay. Tell me whether all of them got a complete octet or not. All of them got a complete octet or not. O3, you got it or not? Tell me. O3 and NH4 plus. O3 and NH4 plus. Tell me, you got the examples or not? O3 and NH4 plus. Tell me if there is any doubt. You got it? Very good. Yes, very good. If there is any doubt, please write. Very good. Can you explain again which part? Rajesh, tell me what you want to be told again. Yes, yes, very good. Very good. Very good. Very good. Okay. Now these are the things that we have to know about bonds. Now let us move to Lewis dot structures. Okay. Lewis dot structures, that is very easy, and we have to do only basic introduction about Lewis dot structures. So it is nothing, it is just the approach in which we show electrons as dots in the different kind of molecules. Is it okay? For example, let us think about hydrogen and hydrogen. Okay, we are thinking of H2 molecule. We are thinking of H2 molecule. Okay, hydrogen and hydrogen we are thinking. Tell me how many hydrogens, how many valence electrons hydrogen have? 1. Here also 1. Okay, and I think duplet is complete. There is no need of drawing this bracket like thing also. No need. Okay, that's it. So this is, or we can more properly we can write it like this. Okay, both are correct, no problem is there, both are correct. Okay, this is for H2. This is the Lewis dot structure for H2. Lewis dot structure for H2. Now let us move to second one. Let us say O2. Okay, very easy. O2. Think about this. Oxygen, oxygen. What you have to draw? 1 2 3 4 5 6. 1 2 3 4 5 6. Okay. Then these two will be bonded. These two bonds will be there. These two electrons will be used as bonding electrons. This and this. Okay, two bonds will be there. So this is a structure of O2. That is a Lewis dot structure of O2. That is very easy. Apart from that, let us move to CO2. Let us move to CO2. Carbon 1 2 3 4, oxygen 1 2 3 4 5 6, oxygen 1 2 3 4 5 6. Okay, so I think these are shared. Oxygen 1 2 3 4 5 6 7 8, carbon, oxygen 1 2 3 4 5 6. Okay, that is the structure. Okay, above one, below one means the same thing. I think you can't see that color. Let me write it properly. 1 2 3 4 5, 6. 1, 2, 3, 4 of carbon, and 1, 2, 3, 4, 5, 6 of oxygen. This is the case. This you can see very easily, I think. This you can see. Very good. Very good. Okay. CO2, O2, these are very easy. Now draw SO2. SO2 you have to draw. Okay. Apart from that, we have to draw CH4. Okay. CH3Cl. Okay. Then I think that is enough. Okay. Let's draw these three, then we will move. Think about these. Think about these. Okay. Do. I am waiting for 2 minutes. Do it. Do it. Very good. Yes, you have drawn. Very good. Done. Very good. Okay, let's do. Very easy. Sulfur 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. Okay, that's it. That's it. This is the Lewis dot structure, and you know there are. This is the actual structure. This is the actual structure. Very easily you can draw. Okay. Think about this. Carbon 1, 2, 3, 4. Hydrogen 1. This hydrogen also 1. This hydrogen also 1. This hydrogen also 1. So it will be carbon, hydrogen, 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 and hydrogen. That kind of structure. Similar to that, CH3Cl 1, 2, 3, 4. One of them is shared by hydrogen, second hydrogen, third also hydrogen, and fourth one will be by Cl, and you know Cl has this kind of things, and carbon will be hydrogen, 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 and Cl, and 1, 2, 3, 4, 5, 6, that kind of thing. Okay, that will be the things, that will be the structures. That is very, very easy. Now let me tell you one more thing. Oxygen, okay, usually forms 2 bonds. Usually form 2 bonds. If oxygen with a negative charge is there, it will form 1 bond. Oxygen with a negative charge will form 1 bond, and oxygen with a positive charge can form 3 bonds. And whenever 3 bonds are there, out of these 2 will be covalent, 2 will be covalent, and 1 will be coordinate. 2 will be covalent, 1 will be coordinate. Similar to that, you can think of nitrogen also. Nitrogen usually form 3 bonds. Nitrogen plus can form 4 bonds, and nitrogen minus can form 2 bonds. Okay, that kind of thing is there. Similar to nitrogen, phosphorus can act similar to nitrogen, 100% same, and sulfur can behave similar to oxygen, that kind of thing. Apart from that, in case of Lewis, fluorine, chlorine, bromine, iodine, these will always be, you will find forming 1 bond only. Okay, usually you will find 1 bond only. In later bonding theories that will come after Lewis, there they can make more bonds, but in Lewis here only they can form 1 bond. Okay, now think about Let us first think. CO3 2 minus, CO3 2 minus. Think about this. CO3 2 minus, CO3 2 minus. It is very easy. CO3 2 minus, that kind of case, very easy. CO3 2 minus. Anybody who has drawn? Anybody who has drawn? Write fast, draw it fast. Yes, very good. Yes, very good. Yes, very good. Done, very good. Done, very good. Done, very good, very good. See, what you have to do is carbon, then 1 oxygen, 2 oxygen, 3 oxygen. 2 oxygens will get negative. Okay. Why? Because 2 negative is there, and out of carbon and oxygen, oxygen is more electronegative, he will get negative. Now, whatever oxygen is there, you know, he will share 2 electrons. Whatever oxygen is there, it will share 1 electron and 1 electron. Is it okay? So, how many are left? 1, 2, 3, 4. That's it. And in this case, 1, 2, 3, 4. 1 from here and 1 from negative charge. That means it will be total 2. Okay. 1 from here and 1 from negative charge. Let me write it like this. Okay. It is there. 1 from here and 1 extra electron due to negative charge. Similar to that, here also 1 due to negative charge, 1 is used here, 1, 2, 3, 4, 5 and 1 more here. Okay. That kind of thing is there. This negative is due to, sorry, this extra electron is due to negative charge. Okay. Negative charge means 1 extra electron. Okay. That's it. Or you can properly write it like this. Just you can leave it like this. Okay. 1 extra electron due to negative charge, and it will make 1-1 bond. See, 1-1 bond only. And if you see its structure, it will be oxygen, double bond carbon, single bond oxygen, single bond oxygen, that kind of. And here it will be negative and negative. This oxygen will have 1, 2, 3, 4. Okay. And this oxygen will have, this means 2, this means 2, this negative means 2. That is the thing. Okay. Negative means 2 electrons. I am just showing it like this. Okay. Negative means 2 electrons. That is the thing. And you can see all of them have complete octet. All of them have got 8 electrons. You draw 7 only, sir. Where 7? 2, 4, 6, 8. 2, 4, 6, 8. Yeah. 1 this shared is also there, na, bro. 7 only. 1 is contributed by this shared one, na. This is a bond, na, bond. So its 2 electrons are counted for this oxygen. 7 only. Getting this? Getting this or not? Getting this or not? Right? Have you got it or not? Right? Have you got it or not? Please write. Superoxide also you can draw very easily, no problem. Yes, got? Yes, very good. Done, got it, very good, yes, very good. Got it? Superoxide also. On the high demand, let us draw superoxide. Superoxide is nothing, it is just O2 minus. Okay, superoxide is what? O2 minus kind of opposite. Mistakenly I have written. Okay, it is nothing, O2 minus kind of thing. Okay, O2 minus kind of thing, it is O and O. Okay, and one negative is there, one guy is having extra electron. Okay, that is, that's it. Okay, and negative. Okay, or we can write, wait a minute, it can be explained like this. Okay, one bond will be there only, and always remember, to explain superoxide there are better theories, don't rely on this kind of theories. Okay, so try not to rely. Actually it will contain half negative with each atom. Okay, so there will be a problem explaining this. Okay, by that theory, so try to get a better theory for this. Okay, try not to explain O2 minus by this. Okay, that's it, you can leave it. Peroxide also O2 minus. Peroxide is also easier. Peroxide is also easier. Okay, peroxide O2 minus. Okay, O2 minus means oxygen, oxygen, one bond, and both of them will have one negative. That means one electron extra, 1, 2, 3, 4, 5, and one electron of negative. 1, 2, 3, 4, 5, and one electron of negative. This is kind of, you can say, peroxide. Peroxide is very, very easy. Peroxide you can explain very easily. Okay, peroxide very easily. H2O2, no, not like that. These things we will later understand. Okay, for now that is enough. Now till here, if anybody has any doubt, you can ask. Till here, if anybody has any doubt, you can ask. H minus, a bad guy. H minus, is it a molecule? Hydrogen with one electron extra, that is H minus. Anybody else? Anybody else? Any kind of doubt? H2SO4, same SO4 2 minus we can draw, and that will not follow that. Okay, let's move. Now let me tell you exceptions of Lewis dot structures. Exceptions of Lewis dot structures. So there are three kinds of exceptions that are there. Lewis dot structure or Lewis theory tells us about the completion of octet, or it follows the octet rule. That means everybody should either complete 8 electrons in its outermost shell, or it should contain 2 electrons in its outermost shell, that is duplet. Okay, duplet or octet. So some of them are known as hypovalent compounds. Hypovalent compounds. What are hypovalent compounds? So these are the compounds which exist, but they do not have 8 electrons in their outermost shell. They are existing, but they do not have 8 electrons in their outermost shell. Example is BF3, you can think. Similarly BH3, similarly BeCl2 kind of compounds. Okay, let us draw them one by one. BF3, that is very, very easy. Boron, that is having 3 electrons in its outermost shell, fluorine that is having 7 electrons, fluorine that is having 7 electrons, and fluorine that is having 7 electrons. Okay, and if you see, there is only this boron has 1, 2 and 3 bonds and no lone pairs. That means it has only access to 6 electrons, 3 of his own and 3 shared. It has only 6 electrons access. That means it is less than 8. Its electrons around boron are less than 8. Then it is known as hypovalent. That means less than valent. We call it hypovalent according to octet rule. That means it is having less than 8 valence electrons in its outermost shell. Okay, less than 8 electrons in its outermost shell. Think about BH3, same you can draw by your own. BeCl2, beryllium have only 2 electrons in its outermost shell, chlorine has 7 and this chlorine also has 7. Okay, so if you see, one bond is this, 2 electrons, and one bond is this, that is also 2 electrons. So how many electrons beryllium has access to? Only 4 electrons, only 4, and that is also less than 8. And all of these are stable compounds, and according to octet rule they should not be stable, but they exist. If they exist in nature, that means this is an exception for octet rule, or this is an exception for Lewis concept. Then comes hypervalent. Compounds. Okay, hypervalent compounds. That is the thing. Okay, what are these hypervalent compounds? So those which have greater than 8 electrons in their outermost shell. If greater than 8 is there, now you will ask me how it can be greater than 8. Think about SO3. How we can draw it? SO3. Sulfur is having 6 electrons. Okay, in its outermost shell, 1, 2, 3, 4, 5, 6. Okay, and you know that oxygen that is also having 6 electrons can very easily share 2 electrons with it. Second oxygen also will share 2 electrons with it, and third oxygen also will share 2 electrons with it. Now think, sulfur is getting this kind of structure, 2 and 3, this kind of structure. Tell me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 electrons are there, and apart from that, these are the lone pairs. This is known as hypervalent species. These are known as hypervalent species. Hello Varun. Is it okay? Anybody has any kind of doubt? Till here? Ask if there is any doubt. 12 electrons. Yeah, 12 electrons, Sanjana. Very good. 12 electrons in its outermost shell. That's why it is known as hypervalent. Now think about one more. Let us say PCl5. P, phosphorus, 5 electrons in its outermost shell. 1, 2, 3, 4, 5 chlorine. That too share 1 electron, like this. Okay, so 1, 2, 3, 4, 5. Okay, so this kind of things. One more thing. This is, and you know 3 lone pairs, because chlorine has total 7 now, only 1 is shared. 6 are unshared. 6 are unshared, like this. So this structure will look like Cl, 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 Cl. Okay, and there are, every chlorine will have 6 unpaired, 6 unpaired, 6 unpaired, 6 unpaired. And if you see how many electrons are there around phosphorus, 4, 6, 8 and 10 electrons. 10 electrons, 10 electrons you can see, 10 electrons are there, 10 electrons are there. So 10 electrons are LiCl, it is not a covalent compound, we are talking about covalent compounds only. LiCl is not a completely covalent compound, it has covalent character but not so much covalent. Okay. Octet rule, I told already that there should be 8 electrons, there should be 8 electrons around any atom to get it stabilized. 10 electrons, very good, very good. Anybody has any kind of doubt till here? Till here, if anybody has any doubt. PCl5 obviously stable, PO4 is nothing, PO4 3 minus is something, PO4 3 minus is something. Very easily you can draw PO4 3 minus, PO4 3 minus, 3 oxygen will contain minus, 1 electron, 1 electron, 1 electron and 2 electron here, rest you can draw by your own. Okay, so this means 1, 2, okay, this you know, negative means 1 extra electron, you can draw by your own, rest you can draw by your own. So this kind of structure, this kind of structure, this kind of structure, this kind of structure, PO4 3 minus, PO4 3 minus. Okay, this kind of structure. Anybody has any kind of doubt, you can ask. Anybody has any kind of doubt, you can ask. Very good. Anybody has any kind of doubt, you can ask. Okay, okay, okay. It is inorganic. It is inorganic. Please write the doubt, whatever doubt is there. No doubt. Very good. If you understood it till here, please write yes. If you understood it, please write yes. Please write yes if you understood. Write fast. H3S3O6, this we will study when we are studying acids. There we will study it. Yes, everybody got it? Write yes. Yes, very good. Write yes. Okay, very good. Very good. Very good. Yes. Okay. Now let us move to next topic, that is calculation of formal charge. Calculation of formal charge. Okay. Formal charge is the charge on individual atom. It is the charge on individual atom in a molecule. Charge on individual atom in a molecule. Okay. So how to calculate it? So its formula is formal charge is equal to valence minus unshared minus shared by 2. Valence minus unshared minus shared by 2. Where what is V? Where what is V? V is the valence electrons. Valence electrons in neutral atom. In neutral atom. U is unshared electrons. Unshared electrons. And S is shared electrons. S is shared electrons. Okay. S is shared electrons. Now think, there is a, let us say, this kind of structure, or we can draw it like not like that. Wait, please. This kind of structure, okay. This kind of structure. Tell me, or before let me tell you, okay. Let us write this oxygen number 1, this is nitrogen, this is oxygen number 2, okay. So formal charge we have to calculate for oxygen. Tell me, how many valence electrons are there in oxygen? So all of us know 6, okay, minus how many of unshared electrons? So you can see 1, 2, 3, 4, that is 4, minus how many shared electrons? 1, 2, 3, 4 shared electrons. 4 by 2, that is equal to 0. Formal charge on oxygen is 0. Formal charge on nitrogen. Nitrogen means 5 valence electrons minus 0 unshared minus 1, 2, 3, 4, 5, 6, 7, 8. 8 by 2, that is equal to 1, that is plus 1. That is the formal charge on nitrogen. On nitrogen, here plus 1 formal charge is there. That kind of thing is there, okay. Similar to that, if somebody asks you like this, tell me on oxygen number 1, oxygen number let us say 2 and oxygen number 3, how much formal charge is there? How much formal charge is there? Sir, could you explain it again? Okay. You try the example of O3, then I will explain it again. See this example and try to do it again, then I will tell it again. No problem is there. Tell me oxygen number 1, oxygen number 2, oxygen number 3, like that you have to tell me. For 1 it is 0, very good. For 1 it is 0, very good. Zero, 0 minus 1. Think again. 0, 1 minus 1. Yeah. Okay, 0, 0, 1, think. Zero, 1, minus 1, very good. Zero, 1, minus 1, very good. Okay. See, oxygen number 1, tell me, for oxygen 1, formal charge is equal to valence electrons of oxygen always 6. Valence electrons of oxygen always 6 minus how many unshared? 1, 2, 3, 4. 4 are unshared. Okay. 4 electrons are unshared. Apart from that, how many are shared? So you can see 1, 2, 3, 4 are shared by 2. Shared by 2. That is the formula. So it will be equal to 6 minus 4 minus 2, that is equal to 0. For oxygen 2, formal charge is equal to, this will be 6. How much are unshared? Only 2 are unshared. And how much are shared? 1, 2, 3, 4, 5 and 6 are shared. So 6 by 2, that is 3, and it will be equal to 1. For third one, what will be the formal charge? So how many valence electrons? 6 minus unshared. 1, 2, 3, 4, 5, 6. 6 are unshared minus, what I should say? 2 are shared. So 2 by 2, that is equal to 1. So 6 minus 1, that is minus 1. So here plus 1 and here minus 1. That is the thing. Plus 1 and minus 1. Okay. Now think about this. That kind of thing. Okay. And sorry, that is my mistake. Okay. One more thing. Whenever there is a plus and minus on adjacent charges, adjacent atoms, whenever there is plus 1 and minus 1 formal charges on adjacent atom, you have to know that this bond is a coordinate bond, and whichever is having plus 1 has given both of its electrons, and whichever is having minus 1 has got the electrons shared. Is it okay? So this kind of thing is there. This is how you can also tell how many coordinate bonds are there. Now think about this one. Okay, this kind of thing. Think about this one. If anybody want anything to be told again. Anybody want anything to be told again? Nitrogen have, no, nitrogen don't have one lone pair. This is the structure. No lone pair here. You calculate the charge, you will get to know why. You will get to know why. Zero, not like that. Tell me on nitrogen number 1 how much, nitrogen number 2 how much, and oxygen how much. On nitrogen number 1 how much, nitrogen number 2 how much. Hmm. 0, 1, minus 1, 0, 1, minus 1, 0, 1, minus 1. 0 1 minus 1, very good. 0 1 minus 1, yeah, I will summarize, no problem. I will summarize, very good. 0 1 minus 1, very good, very good. Could you please re-explain the logic? Yeah, again you just have to apply the formula. This is a formal charge, okay. This means that this charge do not exist actually. This is how much a individual atom should get. This is like that, okay, and you have to just apply the formula and get it, okay. This will be very, very easy. In case of nitrogen number 1, formal charge is equal to valence electrons of nitrogen, that is equal to 5, okay. Apart from that, minus how many are unshared? 2 are unshared, see, 1 2 are unshared, minus shared by 2, 1 2 3 4 5 6, that is 6 by 2. So how much? It is 0, I think. If you solve it, it will come 0. For second one, formal charge, if I calculate, how much? Nitrogen valence electrons 5, minus how much are shared? 2 3 2 4 6 and 2 8. So wait, how many are unshared? 0 are unshared, 0 are unshared. There is no unshared pair of electrons that is appearing. There is no unshared pair of electrons. Now how many are shared? 2 4 6 and 2 8. 8 by 2, that is 5 minus 4, that is plus 1, that is plus 1. Now oxygen, for oxygen formal charge is equal to valence electrons are 6, valence electrons are 6, and how many are unshared? 6 are unshared, and how many are shared? 2 are shared. 2 by 2, 1. So 6 minus 1, that is minus 1. That is the thing. This kind of things are there, okay. This kind of things are there. Now let me give you one more structure. This you will tell, this you will tell again. Oh wait, now it is okay. Try to solve this structure. Try to solve this structure. Try to solve this structure. Let me draw them a little bit dark. Now you can draw very easily. I think all of you can see properly now. I think some of you might have done. Let me name it oxygen number 1, oxygen number 2, oxygen number 3 and carbon. Tell me, oxygen number 1, oxygen number 2, oxygen number 3 and carbon. Very good, Shrikar, very good. Very good. Zero, 0, 1, minus 1. Oh, 0, 0, minus 1, minus 1. 0, 0. Sanjana, take what you are taking. Second oxygen number 2. Check once again. Numbering you should check once again. Very good. Let us see. Okay. So this oxygen number 1, O1, formal charge is 6 is the valence electrons, minus how many are unpaired? 4, and paired are 4 by 2, that is equal to 0. Oxygen number 2, this one is oxygen number 2, okay. 6 minus 6 are unpaired, minus 2 by 2, that is equal to minus 1. Oxygen 3, 6 minus 6 minus 2 by 2, again minus 1. And carbon, if you see, it is 4 minus 0 minus 1, 2, 3, 4, 5, 6, 7, 8, 8 by 2, that is equal to again 0. This is the thing. This is the thing. Have you got it? If you got this question, then you have got how to calculate this formal charge. Tell me how many of you got, please write yes. How many of you got, please write yes. Those who got, please write yes. Those who got the correct answer or understood the answer, please write yes. Now you got it? Very good. Yes, very good. Yes, very good. Very good. Very good. Very good. Very good. Yes, very good. Very good. Very good. Very good. Okay, very good. Is it stable? Obviously, it is a ion. It is not stable. It will be stable with a cation. Okay, it is an anion. It will be stable with a cation. I think that's it. That's enough for today. Okay, that's it. If there is some doubt, you can ask. Else, that's it. Okay. Explain again. Which part you want to be explained again, Shriya? Doubt is there. Which part to be explained again? Oxygen 1, oxygen 2, oxygen 3 or carbon? What you want to be explained again? Please write. Please write. Nothing is there. Nothing is there. Okay, I am explaining just O1 for one time. Oxygen is having 6 unpaired, 6 valence electrons, minus 4 are unpaired and minus 4 are bonded. 1, 2, 3, 4. 4 by 2. So 6 minus 4 by 2, 0. That is the thing. That is the thing. Okay. Similar to that, you can solve others. If you didn't got, please ask me tomorrow. Okay. That's it. That's it for today. We'll meet in the next class.